projects. In this video, we are going to explain about a project titled False Positive Reduction on Lung Nodules Detection in Chest Radiographs by Ensemble of Convolutional Neural Networks. So now coming to the introduction part, the pursuit of false positive reduction on lung nodules detection in chest radiographs by Ensemble of Convolutional Neural Networks marks a crucial step towards refining the accuracy and reliability of lung nodule identification. By uniting the capabilities of machine learning with intricate complexities of medical imaging, this research holds the promise of significantly improving patient outcomes, facilitating informed medical decisions, and contributing to the broader landscape of medical technology advancement. The significance of this research lies in its potential to impact patient care and diagnosis. The ensemble of CNN's approach offers the capacity to detect subtle details and anomalies in chest radiographs and enhancing the system's ability to distinguish between genuine nodules and being structures. So now coming to the objective part for this project, revolve around the development and validation of a novel solution to mitigate false positive outcomes in lung nodule detection through the use of an ensemble of convolutional neural networks. Through the fine-tuning of ensemble parameters, rigorous testing, and comparative analysis, the goal is to create an accurate, reliable, and clinically beneficial tool that enhances diagnostic accuracy, reduces patient anxiety, and streamlines the decision-making process in lung nodule detection from chest radiographs. Another crucial objective is to optimize the ensemble's architecture and fine-tune its parameters to achieve the highest possibility sensitivity and specificity. Sensitivity ensures that the true lung nodules are identified, while specificity helps minimize the rate of false positives. So now coming to the requirements part, we have two types of requirements, that are hardware requirements and software requirements. In hardware requirements, operating system as Windows is required, processor i5 and above, minimum 4 GB of RAM is required, hard disk 20 GB and above. Coming to the software requirement part, Python IDE, that is 3.7 version is required. So now coming to the methodology part, first we have upload JSRT lung nodules dataset. This step involves obtaining and uploading the JSRT, which is stand for Japanese Society of Radiological Technology lung nodules dataset. This dataset consists of medical images, specifically chest radiographs, that have been annotated to identify the presence of lung nodules. Second, generate and load 3 CNN models. After uploading the dataset, the next step is to generate 3 CNN, that is convolutional neural networks models. CNNs are a type of deep learning algorithm particularly well suited for image analysis tasks. These models need to be designed, specified, and trained using JSRT dataset. Training involves exposing the models to the dataset, allowing them to learn patterns and differentiate between normal lung structures and normal modules. Third, upload test image and detect lung nodules. Once the CNN model are trained, the process involves uploading a test chest radiograph image for nodule detection. This image can be from a new or unseen dataset or a sample that was not included during the model training phase. Fourth, exit. Exit represents the conclusion of the specific process being outlined. So now coming to the execution part, to execute the project, first we need to open the code folder. Here we have a folder which is named as dataset. In this we are again containing a folder named as images. In this we are containing some images over here. And here this is the .csv file, which is the dataset over here. The folder named as model, in this we are containing some .h5 files which contain the deep learning algorithms information. These .h5 files can be loaded into the project code during runtime to utilize the trained model for various tasks, such as making predictions on new data, performing specific operations. And the folder named as test images is containing some images over here for testing. Lung nodules detection and train are the two Python files which are containing the Python script in it, and here this is the main Python file. Here this is the run.bat file. Instead of executing the program in command line interface, we created Windows bat file to execute the project. So now to run the project, double click on run.bat file to execute the project. Here this is the graphical user interface. With this we are interacting with the program. Now click on upload JSRT lung nodule dataset button to upload the dataset. Here I am selecting this dataset folder and click on select folder button to load the dataset. So here on this screen you can see that application read and process all images, and then for testing I am displaying one sample image to check whether images are loaded properly or not. And on this screen we can see images loaded properly, and screen showing that small red color boundary box is showing as presence of nodules in image. So now closing this image, Here on this screen we can see application processed all 247 images from dataset, and now image is loaded. And now click on generate and load 3 CNN models button to generate and load CNN models for getting the output. So here on this screen you can see that train CNN I took 10 epochs, and x-axis represents epoch number and here y-axis represents sensitivity. And green line represents sensitivity and here blue line represents false rate, and we can see in this graph that each increasing epoch sensitivity increase and reach to 100% and false rate decrease and reach to 0%. And in this graph we can see each CNN with 3 CNN models got nearly 100% sensitivity. So now closing this graph. Now click on upload test image and detect lung nodules button to upload the test image. So here I am selecting the second image and click on open button to load the image. So here you can see that the uploaded image we can see lung cancer disease detected, and we can see nodules location with red color bounding box. And now closing this image. You can also test with other images also. So now by clicking on the exit button you can exit with this application. So now coming back to the conclusion part. In sum, the endeavor to reduce false positive in lung nodule detection using an ensemble of convolutional neural networks demonstrates the transformative power of advanced technology in healthcare. As this research lays the foundation for future advancements, the promise of improved diagnostic precision, reduced patient anxiety, and more effective medical decision making stands as a testament to the positive impact of innovation in the field of medical imaging. The ensemble method's ability to reverse diverse patterns and features within the chest radiographs is a testament to the power of machine learning techniques in enhancing medical image analysis.
For updates on latest project videos, please visit True Project's YouTube channel and subscribe.